get started. Sorry, it's a bit of an aggressive scroll. Let's get started with our work for today. So on Tuesday, you had a look at the multiplication law for exponents, and that law says to us essentially that we add our exponents together when we are multiplying. Our second law of exponents is working with division. And what this law tells us is that when we are dividing with the same base, we can subtract the exponents. Now, guys, remember, it is so important that we are working with the same bases here. If you work with two different bases, you are not mathematically doing the correct operation or the correct order of work. And so you're going to get a weird answer. So our division law says to us that we should subtract our exponents. Now, in the first example, I'm going to explain to you why that is the case. But essentially, as long as you remember that when you are dividing, you can subtract the top exponent. So that's very important. It's the top exponent minus the bottom exponent, we can get our answer. So I'm just going to put a little thing here. It is always the top or the numerator's exponent minus the bottom or the denominator's exponent. Oops. Right. If we don't do it in that order, we're also going to get a very weird answer. So if we have a look at our first example, I'm going to leave that definition and that law there for us. And we look at our first example. What we have here is a squared times bc divided by 2ac. So if I expand this, I can say a times b times c, all being divided by 2 times a times c. Okay, now the reason I'm doing this is just to show you why the division law is true. If we go and have a look here, we know that when we are dividing by values or by variables, we can cross cancel. So basically what that means is 1a at the top can cancel with 1a at the bottom, as well as 1c at the bottom can cancel with 1c at the top. And so what I am then left with is my simplified answer of a, because I had 1a left, b, because I had a b left, over 2, and nothing else because both the a and the c in the denominator got cancelled. So by cross-cancelling, I'm able to simplify my fraction. Now, sometimes we don't want to have to expand because expansion sometimes is a little bit tedious or a little bit time-consuming. And so we can now try and apply our exponent laws. Now, remember, again, we are working with the same bases. So we can only apply the law to bases that are the same. So here I've got a base of a and I've got a base of a. So those I could apply my law to. And then secondly, I've got a base of c and a base of c. So I could apply my law to that as well. Now, if I just look at the a's, essentially what I have is a squared divided by a. If I just look at that section of my fraction, that is what I'm dealing with. And so if I apply my exponent law there, what it's telling me to do is saying a to the power of 2, so the top exponent minus the bottom exponent, which is 1. Remember, if there's no exponent written there, there is an exponent of 1. And we know that 2 minus 1 is 1. Now, as I just said, we generally do not write the exponent of 1, so that's just a. And if we now go and have a look at the answer that we got previously, there is my a variable. So by subtracting exponents, we are able to simplify our expression. So the division law essentially comes about because of this whole cross-canceling idea. Now, if you would prefer to cross-cancel, that's absolutely fine. There's no saying that you have to use subtraction or subtracting the exponents, but it is potentially a useful way to look at this. So what I'm going to do is I'm just going to make that a touch smaller in case you want to take a screenshot with the definitions and so on. And then we'll have a look at question B. If you want to give question B a try, you're obviously more than welcome to, but then we're going to have a look at question B. So I'm just giving you some time to screenshot. Remember, guys, use the chat for questions. Oratilia, I see your hand.
Hi, ma'am.
Hi.
Ma'am, so ma'am, for question A, ma'am, do we leave it as AB over 2, or is there a simpler way we can leave our answer?
Okay, so we leave it as AB over 2 because that 2 belongs in the denominator. I can't all of a sudden move it up to the numerator because it was originally in the denominator, so it needs to stay there.
Okay, thank you, ma'am.
Okay, good. Okay, guys, so that's really important. That was a really good question as well. Yes, we don't generally like fractions. I know that sometimes we feel like we shouldn't be getting fraction answers, but if a value or a variable was originally in the denominator, we can't all of a sudden move it to the numerator. It's not the same thing. And so because originally that 2, oh, sorry, I'll get there in the end. Because that 2 was originally in the denominator, it needs to stay in the denominator. It can't all of a sudden move its position within the fraction. Boniwe, do you have a question for us?
Hi, ma'am. Can you hear me?
Yes.
Okay. Ma'am, I was asking because there's always my school said there's always like an imaginary 1 in front of a letter that stands alone, maybe. Right? So is they here? Because yeah, that's what I'm asking.
Can you repeat the last little bit again? Sorry, you cut out for a second there.
Sorry, ma'am. I was saying, right, there's always an imaginary 1 in front of a letter. So, ma'am, don't we say 1 divided by 2? Because, yeah. So, isn't that what we're supposed to do?
So you can. So there's that imaginary 1 or that invisible 1 that you're talking about. And so if you want to put the 1 in front of the AB, you're more than welcome to, but you don't have to. So if you want to write 1AB divided by 2, that's absolutely fine.
Okay, thank you.
Okay, guys, so again, like it's absolutely fine to write that 1 in front of the AB because there is a coefficient of 1 there. We don't generally write it, but it's not wrong to write it. And so if you're more comfortable putting it there, rather leave it there. That's absolutely fine. I need to do some jumping jacks when we do a break because I gotta get my energy up. Alrighty, guys, so let's have a look at question B. Now, question B, there's a fair amount going on here, but we just take it slowly. Now, again, there's so many different ways that you can do this. You need to decide what makes sense for you. So what I always do, my first sort of thought is always, can I simplify each fraction first? So can I simplify the individual fractions? Because if I can simplify the individual fractions, it means that I'm making my life a little bit easier before I start multiplying and dividing. So question number 1, can I simplify my original fractions or my initial fractions or my individual fractions, whatever you want to say? And so we go and double check. So if I look at my first fraction, I've got AB squared over A. So my first fraction, can I simplify it? Well, yes, because I've got a division of A divided by A. And guys, remember, we know that whenever we divide something by itself, we get 1. So the same thing happens with A. A divided by A is 1. Essentially, they cancel each other out. And so from the first fraction, we've got B squared over 1. I have simplified. If I then move on to my second fraction, I've got A squared, B squared over B. If I now consider what that fraction is saying to me, because I've got the same B bases over there, I could potentially go and use my division law. So again, B squared divided by B would mean that B is to the power 2 minus 1. And so we actually just have B here. Alternatively, think about your cross cancelling. Oh, sorry. My 1B at the bottom can cancel with 1B at the top. And so what I'm left with in my second fraction is then A squared B over 1. Now, finally, my third fraction, I don't have any like bases there, which means that I can't simplify. I've got A, B, and C, which are all different bases, so I can't actually do anything with that. And so it's going to stay exactly as it is for now. So once I've simplified my fractions, this is now where I start to multiply. Now remember, guys, when you multiply fractions, we multiply all of the numerators together and we multiply all of the denominators together. That is how we multiply with fractions. So here I've got a numerator of b squared times a squared b times ab, all over 1 times 1 times c. So I've multiplied all my numerators together, all of my denominators together. Now remember, you can only apply your exponent laws when you have like bases. So here we've got a base of b, here we've got a base of b, and here we've got a base of b. Remember, of course, if there's no exponent written, there is actually an exponent of 1. It's very similar to that ghost 1 or that 1 that we put in front of our letters. We just don't write it in. We also see that we've got like bases for the a. So we've got an a squared and an a. Again, that a on the end there has an exponent of 1. Now this is going back to, so if you missed Monday's lesson, Tuesday's lesson, because we're multiplying, this takes us back to law 1 of our exponents. That tells us that if we are going to multiply two values with the same base, what we can do is we can go and add the exponents to get our simplified answer. And so if we have a look at the a's, and we always try work in alphabetical order, a squared times a would actually be a to the power 2 plus 1. And when we look at our b's, that would be b to the power 2 plus 1 because of the b's and the b squared that I'm multiplying. In the denominator, we know 1 times 1 is 1. And so what we actually just have in my denominator is c. And now I can simplify my exponents. We know that 2 plus 1 for the exponent of a is 3. And we know 2 plus 1 plus 1 plus 1 for the, I think I said too many ones there. 2 plus 1 plus 1 for the exponent of b is an exponent of 4 all over c. I have no like bases. I've got no bases that are the same, which means that I cannot simplify any further. And so I have simplified this whole expression. And guys, what we need to start realizing, and we'll do more and more and more of these, is that often we have to use more than one law as we do a question. It's very, very rare that we ever get asked a question where we only use one of our exponent laws. Often we have to combine them. So I'm going to stay here in case anyone has a question. I also see some hands. So Tabatso, do you have a question for us? Or for me?
Hi, ma'am.
Hi.
Oh, okay. I was trying to say that you did you made it long, and I just don't understand what's going on. Can you please like do it again, but then shorter? Or there's no short method there?
I mean, there isn't really a shorter method to do it. This is pretty much as short as it gets.
Can you please re-explain it?
Okay, I'll go through it quickly, but remember you can get the recording. So what I said was initially what we can do is we can see if we can simplify the individual fractions, which is what I did in the blocks over here. So for example, in the first fraction, I saw that the a could cancel with the a in the denominator, and so I simplified, leaving me then with just the b squared in my numerator, because that was the only thing I didn't cancel. So I did the same thing for each of my fractions. I saw if I could simplify them, and only then did I apply the multiplication. So only then did I decide to multiply everything in my numerators together and everything in my denominators together. So that's what the step in green is showing me. It's showing me that I'm multiplying my fractions. When I do that, what I then need to remember is that because I'm multiplying, I'm applying law 1, which says that we can add exponents when we multiply. And so that's why over here in step 3, I'm choosing to add all of the exponents that have the same base. So all of the B's exponents I added together, and then all of the A's exponents I added together, because that's what my law 1 says. And once I'd done that, I could then write my final simplified answer. Okay, so I hope that makes sense. And guys, sorry, my camera's just off because my internet seems to be having a bit of a problem. I'm hoping it's going to recover itself now and I'll put it back on. But I'm just giving it a second. All right, Orotile, question?
Ma'am?
Yeah.
Ma'am, my question is, ma'am, for where you wrote law 1, ma'am, you said x to the power of 2 plus 3, ma'am. And then you said x is equal to 3, ma'am. Isn't it equal to 5, ma'am? Or
Yes,
am I
thank
wrong?
you. No, you are right. Sorry, thank you.
Thank you, ma'am.
Thank you so much, Orotile. Tandor?
Hello, ma'am.
Hi.
So, ma'am, I just wanted to find out. So, on the final answer that you got for activity B, I just wanted to find out. I also got the same answer, but then I didn't write A to the power of 3 and B to the power of 4. Instead, I switched them around and I wrote B to the power of 4 and times A to the power of 3. So I just wanted to find out, is the answer still correct or is it wrong?
No, your answer is still absolutely fine. It's perfectly correct. We try and write our variables in alphabetical order, but as long as the base and the exponents are the same, so as long as A has an exponent of 3 and B has an exponent of 4, it means exactly the same thing. Like I say,
Okay.
try write it in alphabetical order, but it is the same thing.
Okay, ma'am.
Okay, good. So guys, I'm just going to add a little note here. So if you have taken a screenshot and you want to just add this to, we try write our variables in alphabetical order. It just makes things a little bit easier to work with, especially when you're starting to try and identify like terms. Okay, but you don't have to, but like I say, it does make your life easier when you start trying to get like terms to add or subtract in an expression. Right, we're going to try one more and then we'll take a little break. So make sure you've got your screenshots here. I'm going to move away now. Righto. So question C, I want you guys to have a go. What might be easier for you is to write this as a fraction, and often I always do this. Whenever it gives me a division sign, I always go and write it as a fraction, because then I can see what exactly I'm dividing, what exactly I can simplify, and for me, it makes it a little bit easier. You don't have to. If you're comfortable with the division sign, that's cool. But I want you to try C. And remember, guys, we've spoken about this quite a few times. Whenever we are trying to divide or multiply, and then I go and put a plus sign. So whenever we times or multiply, remember S and V. Figure out what your sign should be first, then go and divide or multiply your numbers, and then go and divide or multiply your variables. If you do it step by step in order, don't rush it, you should simplify absolutely fine. Right, so remember your laws. And again, guys, often there's a couple different ways to do the same thing. So in this case, I'll show you 2 different ways that you can simplify this, mostly because I actually never use subtraction of exponents, and that's just a personal preference. I generally do it the second way that I'm going to show you, but that's easier for me. You need to decide what makes sense for you, and you need to use that method. Okay, and that's sort of what's quite nice about exponents is often there's different methods that we can use to get exactly the same answer. It's whatever makes sense to you, and as long as you apply your laws correctly, there's no problem with doing it slightly differently to the way your teacher might, or to the way your friend might, or to the way a tutor might, or whatever the case is. Follow your laws, follow your steps, you will be fine. I see there was a question in the chat from Michael. We will send the quiz link in the last 5 or so minutes of the lesson, so you can grab the quiz link there, and then you're able to access the quiz. Oh, Melissa's on it. I don't know why I overstress. Remember, guys, answers in the chat so we can see. I'm seeing some answers coming through. Getting there slowly. Guys, remember the operation you are dealing with is division. We are not saying 3 times 6. We are saying 3 divided by 6. Okay, we're getting quite a mixed bag of answers here. So I'm going to go through this one, and then hopefully we will just start to grow and grow in confidence. So guys, I'm going to follow SNB. Let's do that. So start with the signs. I'm dividing a positive by a positive. We know that whenever we say positive divided by a positive, I end up with a positive. So my signs is done. I don't actually need to stress about it because everything was positive. There's no problem. Now I move on to my numbers. So the numbers that I'm dealing with are 3 divided by 6. Now, guys, what we need to be careful of is the fact that my denominator is bigger than my numerator. The second that happens, I'm probably going to have a fraction, or I am definitely going to end up with a fraction, not an integer. Now, remember, when we simplify fractions, you can do it on your calculator, but what we do is we ask ourselves what number can divide into both of these. So we know that 3 can divide into both 3 and 6. That will simplify this fraction. And so this fraction simplifies to 3 divided by 3, which is 1, and 6 divided by 3, which is 2. So in terms of my numbers here, I now have 1 over 2. So that's my numbers done. I then move on to my variables. So if I look at my variables here, the variables I'm working with, that is an aggressively thick pen. Let me just make that a touch thinner. If I look at my variables here, I've got x to the power 6 divided by x to the power 4. Now, if you're going to apply your exponent law, that tells me to take my top exponent and subtract my bottom exponent. And so x to the power 6 minus 4 is actually just x to the power 2. Now, what we need to always double check is where was the bigger exponent? The bigger exponent was in my numerator. So wherever the bigger exponent was, that is where my answer must go. So my answer must go in the volume's Molly. Don't know what's happening. Sorry, guys. My answer must go into the numerator. It's not possible. And so that x squared will sit at the top. If my bigger exponent was at the bottom, it would sit in the denominator. And so what we get here is that my final answer for the simplification is 1x squared over 2, or remember, you don't have to put the 1 there, x squared over 2. Excuse me. So either way that you choose to write your final answer is absolutely fine. You can have the 1 there, you cannot have the 1 there. But as long as you go step by step and do your signs, your numbers, and your variables, and apply your exponent laws to your variables, you will be absolutely fine. Tandor, question?
Ma'am, I don't understand how you got to x squared over 2, because after you divided with 3 for 3 over 6, you got 1 over 2. Shouldn't the answer then be 2x to the power 2 over 2?
Okay, so remember, the 2 is in the denominator, so it has to stay in the denominator. Whereas my x squared is in the numerator, so it has to stay in the numerator. So they have to stay in these respective parts of the fraction.
Okay, ma'am.
If that doesn't make sense, I'm going to show you a slightly different way to do it, and that will probably explain a little bit better why it's x squared over 2.
Okay, ma'am.
Tabato, I do see your hand. Let me just do this second way so that hopefully everyone's a little bit clearer, and it might even answer your question. So listen up. Okay, so guys, like I said, I don't like the division law. I don't know why I don't like it. I clearly have some personal issue with it that is deep-seated and I don't know what it is. What I choose to do is I choose to think of this as an expanded product. So 3 times x, 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 x. So I've got 6 x's there because that's what x to the power 6 means. Divided by 6 times x times x times x times x. 4 x's because it's x to the power 4. Now, all I do when I've got this is I go and cross cancel. That's the point of me doing this. So I can cancel 1x with 1x in the denominator, 1x in my numerator with another x in my denominator, a third x with a third x, and a fourth x with a fourth x. I stop there because I've got no more x's to cancel my denominator. I'm now done. So what that's telling me is that in my numerator, I've got 2 x's left. Hence, the x squared in my numerator. I also double check my numbers. For the numbers here, I know that I can divide both of these by 3, which is what we said earlier. And so if I divide 3 by 3, I get 1. And if I divide 6 by 3, I get 2. So again, I'm noticing that my 2 is in the denominator. And they have to stay where we've put them. They have to stay where they should be. So those x squareds, remember that I've highlighted in blue, stay in my numerator. And the 2 that I've highlighted in green stays in my denominator. That's where they belong. We can't move them. They stay where they're supposed to be. So if you prefer a cross-canceling sort of idea, that's absolutely fine. Okay, so the x squared has to be in the numerator because I had 2 x's left at the top, and the 2 has to stay in the denominator because that's where my remainder of 2 was when I divided 6 by 3. All right, so that's all question.
Ma'am, I wanted to know because I wrote a different answer. I didn't do it with a fraction. I wrote 2x exponent 2 without doing it as a fraction. Is it right?
No, so I've just explained why not. So have a look at what I've done there, and the 2 should be in the denominator.
Okay, ma'am. Thank you.
Okay, so have a look at what I did. And if you need to, guys, remember you can go back and watch the video. I just explained it there for us. And Tombi, do you have a question for us?
Hi, ma'am. Can you hear me?
I can.
Ma'am, is it a must like to put x squared? If you don't put x squared, what will happen? Like, if you didn't like put the x squared?
You have to have x squared because there's 2 x's left over. We can't just ignore those x's. So these x's in my numerator here, I still have to write them down. So I have to put an x squared because that's telling me that they are remaining.
Oh, ma'am. Okay, because like I didn't put the x, but like I added the squared. So I have to add the x. It's a must.
Yes, because the x is the variable. So if we just forget it, then we're forgetting a complete value. We need to remember that it is there.
Okay, thank you, ma'am.
Pleasure. Atini, question?
Afternoon, ma'am.
Atini, you there?
Ma'am.
Yes, okay, I can hear you.
Ma'am. Okay. Ma'am, I wanted to ask, let's say we wrote it as 1 over 2 and then the x was not in the numerator line, but like in the middle. Does it like generally just fall into the numerator line, or is it like just stuff like that?
So if you wrote it as a half x squared, like what I've done here in the red block, that's fine. That's the same thing. Because what this actually means is that it's a half times x squared. And so the x squared would go into the numerator. So like I say, when we subtract and look at our division law, because we had the bigger exponent in the numerator, we knew that the answer went into the numerator. But if you want to write it as a half and then x squared next to the half, that's fine.
Yes, ma'am. Thank you, ma'am.
Good, guys. Guys, remember, I know that exponents is not necessarily the easiest topic. I do understand that. So we're going slowly, making sure that you are doing these questions, practicing these questions, because if you decide to take maths until matric, this is going to stick with you. Exponents is going to stick with you all the way. So it's really important that we get these basics. Okay, so let's take a little break because I feel like it's been a lot of information. Whoopsie daisies. Here's your brain break for the day. So I just want to make sure we all understand what this is saying. So we've got a small square inside of a larger square. Now remember, square is a special type of shape where all four sides are equal in length. So if one side is 2 centimeters, all sides are 2 centimeters. If one side is 7 centimeters, all sides are 7 centimeters. The perimeter of the shaded region is 24 units. Now, guys, remember, perimeter is the outside length. So if I always, that's a terrible color to have chosen. Sorry, let's try that again. I always think of perimeter as if I put a fence around my shape. So if I was to put a fence around the shaded area, that is the length of fencing I would need. That's the perimeter. So my question here is, what is the area of the largest square? And the largest square is now the one I've done in purple. So have a think, have a try. See if you can tell me what you feel the area is. If you should, don't stress. Finance does come up in maths. It might just not have been covered for whatever reasons. It will eventually get there, okay? It will. We will eventually get there. Anyone got any ideas for our square? What is the area? I've really given you a challenge this week, so don't stress if you're struggling. It's good. I did challenge you today. Ooh, guys, I'll give you another minute or so and then we'll have a look. But answers in the chat. Lots of different answers coming through. Nice. I'm glad I'm getting something. Remember, guys, you want an area. The area of a square we find by saying the side times the side, or you can think of it as length times breadth. An area should then always be in units squared. So your answer should be centimeters squared. Okay, some people are on the right track. Just remember, we want an area. Nice, guys. Well done on trying. This was a tricky one. I was mean today, but every now and then I am. Okay, let's have a look. So we've got our square, and the information that we know so far is that the perimeter is 24 units. Okay, now I've already explained what the perimeter is, but basically it's this outside length. Now what I want you guys to notice is the fact that if we took this portion of the square and we put it down along the side, And if we took this sort of portion of the square and we put it down on the side, what I would actually get is the full square. So if I just sort of rearrange my sides a little bit, I get the full square. So basically the 24 units is the perimeter of the whole square. That does not look like a square. Let's try that situation again. Perimeter of the whole square. Now remember, the square has equal side lengths. So all of those side lengths are equal. Now, if altogether those 4 side lengths are 24, so 4 sides gives me 24 centimeters. One side is 6 centimeters. So all of these side lengths are 6. If you add 6 4 times, you get 24. If I then want the area, and remember area is now the space it occupies, and like I said, area is side times side, all I would need to do is say 6 times 6. And so the area of the square is 36 centimeters squared. So some of you were on the right track there with those 6s. As was a tricky one, so well done on trying. And we were so close with some of them. Just remember we were asking for area. But very nicely done, guys. Well tried. Okay, I don't know if you want to take a screenshot of this, but I'll wait here for a few seconds and then we're going to go and practice a little bit more. Good, Chichi, and it should remind you of radius and diameter and length work and all of that fun stuff because it's all part of measurement. And so it's still mathematical. It still has something to do with maths. It's just a little break from exponents. Okay, guys. So, whoopsie daisies. Let's have a absolute chaos going on there. Let's have a look then at question D. Okay, so we're going to do this nice and slowly. We're going to do it together so that everyone's on the same page. I've got my fraction of 3x cubed times y squared divided by 3xy times 6x over y divided by 2x. Okay, so again, my first question is, can I simplify each individual fraction? Now, just a reminder, this 2x can be written as 2x over 1. So we can make everything a fraction if we feel we want to. But let's first simplify each individual fraction. So let's start with this x cubed y squared divided by 3xy. Remember, we're going to use our SNV, so signs, numbers, variables. Over here, I'm dividing a positive by a positive, so I'm going to get a positive. If I move on to my numbers, whoopsie daisies, remember, as we've been told, there is a 1 in front of that x cubed, and so 1 divided by 3 is actually just 1 over 3. Nothing changes there with my numbers. But then I move on to my variables. Now remember, we need to use the same basis. So I'm going to start with the x's. If I take those x's out, I'm looking at an x cubed divided by an x, which means that if I want to apply my exponent law, I've got x cubed minus 1, which gives me x squared. Now remember, like I said in the last example, look at where the bigger exponent was. The bigger exponent was in the numerator, which means that my answer of x squared must go in the numerator. Then I go and have a look at my y's. So I've got y squared divided by y. Similar sort of thing that I need to do here. I'm going to take the y's out, so y squared divided by y. If I apply my exponent law, y to the power 2 minus 1, and so I'm left with y. The bigger exponent was again in the numerator, so my y goes in the numerator. So this first fraction simplifies to x squared y over 3. If you want to put the 1 in front of the x squared, you can. Ortile, do you have a question before I carry on?
Yes, ma'am. So, ma'am, does SNV apply to all topics in maths, ma'am?
So basically, yeah, as long as it's dealing with, as long as you're dealing with division or multiplication, SNV applies. Whether it's exponents, whether it's algebra, whether it's integers, it can apply.
Thank you, ma'am.
Good. Okay, so guys, we've simplified our first fraction. If we have a look then at the second fraction, just by looking at it, I can see there's nothing I can simplify. There's two different variables. There's no number in my denominator that I can simplify with 6. And so my second fraction can just stay exactly as it is. So times 6x over y and divided by the 2x over 1. Now remember, when we are dividing with fractions, what we need to do is tip and times. I can't remember now if it was in this class, but there was also a KFC, which I quite enjoyed. It was in this class. Okay, so if you don't know KFC, keep the first fraction, flip the second fraction. So let's say keep first, flip second, change the sign. So change the multiplication. And I like KFC. So I'm now using that from now on. So we've now got x squared y over 3 times 6x over y. So I keep my first fraction. I flip the second fraction to be 1 over 2x, and I change my sign. Right, so guys, now I can go and multiply. So I'm going to multiply all of my numerators together and all of my denominators together. So when I do that, I've got x squared y times 6x times 1 all over, sorry, there's a weird division sign going on there, all over 3 times y times 2x. Now again, just as Ortile said, we can apply SNV. In our numerator, let's start with our numbers. We've got a 1 times a 6 times a 1. That gives me 6. Then I go to my variables. Remember, same basis. So I do the x's first. X squared times x gives me x cubed. Now there's only one single y. Shame. He's all by himself, but that's fine. He just stays there. Then in my denominator, same thing. Signs, everything's positive, sorted. Numbers, 3 times 1 times 2 gives me 6. I've only got one x, and I've only got one y, so 6xy in my denominator. Now we always double check, guys. We always see if we can simplify. And this time what I'll do is I'll expand so that we can see what we're working with. So 6x cubed is 6 times x times x times y, all over 6 times x times y. I can cross cancel what's common. So 1x in the top, 1x at the bottom, 1y at the top, 1y at the bottom, and the 6 at the top and the 6 at the bottom. And so actually all I have left are those two x's. They're in the numerator, so I write it as x squared. I've got nothing left in my denominator, so I could write over 1 if I wanted to. But remember, anything over 1 is just that thing. So I can actually just leave it as x squared. Okay, so I know this is a lot of information, grade 9s. Please don't stress. We will do many, many, many more examples. But what is really important is that you go slowly. You do it step by step, and you apply SNV or KFC or whatever, depending on the question. So KFC is if you're dividing with the fractions. SNV is so that you make sure you multiply and divide correctly.